Alright, we're looking at guidelines for finding inverse functions in simple cases. Remember, an inverse function is a function that does the opposite of whatever the original function does. So if, for example, function of x does one thing, then the inverse function of x should do exactly the opposite thing. The first step is to verify that f is a one-to-one function throughout its domain. This is important because if a function is not one-to-one, it doesn't have an inverse. The second step is to solve the equation y equals function of x for x in terms of y, obtaining an equation of the form x equals inverse function of y. Now let's look a little bit at what that means. Alright, so let's take the function of x equals 2x minus 7. And our first step is to verify that the function is one-to-one. A good way to verify that is to let function of a equal function of b. If this is impossible unless a equals b, then it's one-to-one. So let's say function of x equals 2x minus 7, so function of a equals 2a minus 7, and function of b equals 2b minus 7. Let's add 7 to both sides, and we get 2a equals 2b. Let's divide both sides by 2, and we get a equals b. So we've verified that this function is indeed one-to-one. Alright, the next step, like it says right here, is to solve the equation y is a function of x for x in terms of y, obtaining an equation in the form x equals inverse function of y. So we're going to take the equation y equals function of x. Well, if the function of x is defined as 2x minus 7, then we could rewrite this as y equals 2x minus 7. So that's our equation y equals function of x. Alright, and now we're going to solve this equation for x in terms of y. That means we've got to isolate x on one side of the equation. So let's start by getting rid of this 7 here. So let's add 7 to both sides. We get y plus 7 equals 2x. Now we can just divide everything by 2, and that should give us x equals y plus 7 over 2. So what we just did was we solved for x in terms of y. And this actually could be rewritten as x equals inverse function of y. Alright, now all we need to do is switch the variables x and y. Well, that's easy. We just have, instead of x equals, we have y equals, and then x plus 7 instead of y plus 7 over 2. And that gives us y as an inverse function of x. Alright, so now we have if function of x equals 2x minus 7, then inverse function of x equals x plus 7 over 2. Alright, there we go. We've just found our inverse function, and let's see what the next step is. The next step is just to verify it. So we have to verify the following two conditions. Inverse function of x equals x for every x in the domain of f, and function of the inverse function of x equals x for every x in the domain of inverse function. Now, of course, that sounds like a mouthful and it's a little confusing, but let's look at a little bit at what it means. Alright, we said at the beginning that an inverse function does exactly the opposite of what the inverse function does. So in this case, the original function multiplies everything by 2 and then subtracts 7. Well, what does the inverse function do? The inverse function adds 7 and then divides everything by 2. So it does exactly the opposite of what the original function does. It's doing the opposite things in the opposite order. That's why it's called an inverse function, because it does exactly the opposite. So if we have a number, and we're going to do one thing to it, and then we do the opposite thing to it, we should get exactly the same number we started with. Whether that's, for example, if we take a number, we move it, move it up, and then we move it down, it's going to get back into the same place it was. We could take a number, we could double it, and then we could cut it in half. That would mean function of x equals 2x, inverse function of x equals 1/2 x. Well, if we take a number x, say x is 10, we double it, we get 20, we cut it in half, we get 10. So we're going to do the function to it, and then do the inverse function to it, and get exactly what we started with when we finish up. So the first thing we want to do is say if function of x equals 2x minus 7, what are we going to do when we take this result and put it into the inverse function? Well, the inverse function of x, let's take the inverse function of x, and if the inverse function of x is x plus 7 over 2, then the inverse function of x should be function of x plus 7 over 2, right? So that's the inverse function of x. Now let's remember what function of x was. It was 2x minus 7. So let's now plug 2x minus 7 into that formula here. So instead of function of x, we have 2x minus 7. Now we have 2x minus 7 plus 7 over 2. Okay, now let's just simplify this thing a little bit here. We can just get rid of the parentheses. So we get 2x plus 7 minus 7 over 2. Oh look, these 7's cancel. 7 minus 7 is 0, right? And then we notice that we have 2x over 2. Well, 2 over 2 is just 1, so that cancels. And we're left with x. So we see that the inverse function of the function of x equals x. This looks like a complicated equation, but all it means is that we did one thing, and then we did the opposite, and then we got back what we started with. So we did one thing to x, did the exact opposite of that to x, and then we ended up with x. That's all it means. Now, this says to verify two conditions. First we do the function, and then we do the inverse function to it, and we should get what we started with. Well, it also makes sense that if we do the inverse function first, and then do the function, we should also get what we started with. So let's try that. Alright, first we're going to start with the inverse function and then plug it into the function. So the inverse function is x plus 7 over 2. We're going to plug that into the function. Function of inverse function should be 2 times inverse function minus 7. Alright, let's place that into here. So inverse function of x is this. Let's just plug that into this right here, and we get 2 times x plus 7 over 2 minus 7 is this. Alright, now we can notice that this 2 cancels with this 2 because 2 over 2 is 1, and we're left with x plus 7 minus 7. Of course, the 7's cancel, and what we get is the inverse, or the function of the inverse function of x equals x. So again, we did one thing to x, then we did the exact opposite of that thing to x, and we ended up with just x. And at the end, it just says, note that we must have an appropriate match between the domains of function of x and the inverse function of x. So the domain of the inverse function is the range of the function, and the range of the inverse function is the domain of the function. Now in this case, our domain of 2x minus 7, the domain of that is negative infinity, infinity. And its range is also negative infinity, infinity. Now so the domain is that, range is that, and then we have x plus 7 over 2. Its domain should be the range of the original function, and it is. And then its range should be the domain of the original function, and it is. Alright, now if we want to explore that a little bit more, let's look at one more function here. Now if we look at this the domain of this function right here, we see that the domain goes from -2 to 1. And it's inclusive. These are solid filled lines. So -2 to +1. If we look at the range, we'll see that the range goes from about 1/2 to about 2. And again, it's inclusive. Now if we look at the inverse function of this, it will look something like this. Alright, here's the inverse function. Now, the domain of this function is going to go from about 1/2 to about 2. So we've got our domain equals inclusive from 1/2 to 2. Because the x values that's defined for go from x equals 1/2 all the way up through x equals 2. And then our range goes from -2 to +1. And we can see that this is exactly the inverse of what we had originally. Instead of the domain going from -2 to 1, we have the range going from -2 to 1. And instead of the range going from 1/2 to 2, we have the domain going from 1/2 to 2. Here are the two functions side by side, so that you can see that they're inverses of each other. There you go. And now we can see that the domain and range of an inverse functions are opposite of each other. The domain of the inverse is the range of the original, and the range of the inverse is the domain of the original.